In part B, we can see that this is a quadratic equation again. There is an x squared, an x, and a constant term. So we can use a quadratic formula here. It's equal to 0. So what we have to do is identify the a coefficient. So that's going to be the a coefficient, the b coefficient, which is negative 3m. Okay, I'll do that different color. That represents a coefficient on x. And then there's a constant term, which is going to be plus 2. So I can plug this into my quadratic equation. I'm going to end up with my quadratic formula, It's going to be negative b, so negative of negative 3m. So it's going to be positive 3m plus minus the square root of 9m squared minus 4 times a, that's my m squared, times c. Okay, so I'm just going to color code this a bit. So there's my a value, there's my c value, and my b value is going to come from those two parts there. My denominator of my quadratic formula is going to be 2 times a, which is m squared. Okay, so those represent the a, b, and c coefficients of that quadratic equation, which I can put into the quadratic formula. So working this out then, so I have my answer here, but I need to simplify that solution. So I get 3m plus minus square root of, this becomes 9m squared minus 8m squared, which just gives me 1m squared. So now I can square root that and get my solution. Now, one thing we should recognize, and this is, if we don't need to do this, but if the square root part is rational, so if I can square a perfect square and I can perfectly square root that, that means that the solution must be rational. It's not like it doesn't have a radical in it, and which also means that it must be factorable. So this question actually was factorable. So I get 3m plus minus square root of m squared is m over 2m squared. When I actually work out the solution for this, 3m plus m is 4m divided by 2m squared. So 4 divided by 2 is 2. M divided by m squared is m in the denominator, so 2 over m. The other solution is when I subtract. 3m minus m is 2m, so 2 divided by 2 is 1. M divided by m squared gives me m in the denominator, so those are my two solutions. And since they're rational, this means that this must have been factorable, and in fact it was. It follows the quadratic pattern, m squared, mx all squared, mx, and then the constant. So this actually factors to mx, mx. We're looking for two numbers that multiply to 2 and add to 3, negative 3. That's going to be negative 1, negative 2. This is equal to 0. I can solve this by factoring. So x from this bracket is equal to the opposite of back divided by front. There's one solution. The x from the second bracket is going to be the opposite, so positive, back divided by front. And so that gives me my other solution. So this is the quadratic formula solution. The fact that this is a perfect square tells me that it was factorable, and I can actually factor and solve this.